My name is Tiago Luchini. Thank you very much for joining me for the next 35 minutes or so. We're going to be talking a little bit about declarative domain modeling and its application for Datomic Ions, some of the stuff that we have been doing with Datomic Ions and Datomic Cloud as well. But before that, just a quick primer. I'm a technology partner at Work & Co. We build and design very cool digital products. You should definitely check us out. You know, in the last few years, we have grown from 5 people to almost 270 people now. And myself, for the last 20 plus years, I've been in this industry, and my passion particularly is bridging business and technology. And there's a lot of stuff that we as engineers can learn from business, and there's a lot of stuff that some of us who also have a background in business can also learn from technology. I do hope that some of that stuff shows through in this presentation as well. So a little bit of the outline of like how we're going to be tackling this today. We're going to start with what declarative domain modeling is. Then we're going to go a little bit deeper into Datomic Cloud and Ions. And I really want to actually provide you guys with a reference application as well at the end, basically putting everything together so that you can go on GitHub and download it. But even before I start this, just show of hands, how many of you have already at least played with Datomic Cloud and Datomic Ions? Awesome. How many of you are planning on using it in production? And how many of you are using it in production already? Awesome. That really helps as well. So before we go into Datomic Ions, let's talk a little bit about descriptive domain modeling. And I think that in software development, it's really hard for us to agree on things. We disagree on processes, we disagree on languages, we disagree on interfaces, we disagree on so many things. But there is one thing that I think we all relate very much, and it is a good whiteboarding session. It's the one technique that survives them all, right? Like, we talk about waterfall and agile and then safe and whatnot, but at the end of the day, like what really works is a bunch of engineers, a bunch of business people, a bunch of designers sitting on a room and whiteboarding, just with different colors, different pen, erasing stuff and moving stuff around. This is actually just from a project. Like, I just entered one of our rooms randomly and I took a picture. And we love drawing stick figures and boxes and arrows. Like, that's what we like. And in fact, I think that for us engineers, this is so efficient and so beautiful that sometimes I see it like this. It's like almost like art a little bit. And the fact about this kind of exercise that we do, this whiteboarding and modeling, is that we have been modeling for quite a while. So every time that I talk about domain modeling, people quickly refer to domain-driven design by Eric Evans from 2004. He was really looking at the domain modeling and like context boundaries and things like this. And there is even an interesting follow-up work by J.P. Tolvanes on how to apply that kind of a principle, those kinds of principles into DSLs and even generate some code. But this goes even much further back. If you really like history of computers and engineering, there is this whole idea of model-driven engineering all the way from the 80s, and this was later applied via a very specific, very thorough specification by MDA, called MDA by the object management group, back in the early century. But all these things, all these different approaches and practices, they're basically saying, like, the domain model is the core of what you're trying to solve. And I think that because of some of the story and some of the object orientation that there is in that space, we in the functional area, in the functional side of things, we tend to actually not pay attention to that. But I want to give it a little bit of a functional spin when we talk about domain modeling in general. And this is the way that I have been trying to describe functionally how to organize some of these ideas. And in my mind, everything we build, every single system we build is always a gigantic function. It's one big function that actually has 3 major inputs: logic, state, and model. And I'm going to go deeper into each one of these guys. Logic is probably the easiest because that's the one we probably know the easiest as well. Like it's just a collection of functions, right? Like you write functions that represent the logic of the system you're trying to solve. State is a little bit more complicated, and we have had so many different ways of looking at state. Personally, the way that I like looking at state, it's that it's another function that collects the initial state and all the transactions that have happened, all the assertions that have happened until you get to the present state. Of course, I don't have to represent the present state as well here because it is just the fold of everything, right? Very Datomic-like or event sourcing, if you will. The model, however, I think that we also have to break down into two different parts. One is the business or domain proper part of the model, and the other one is mechanical aspects that support that business model, that domain model. Or, if you want to express as a function, the function of the domain model proper and the mechanical aspect of it. What do I mean about these things, right? So let's use an example of a domain model or something that we all relate to. Most of us are employed. Most of us have employment somehow. So let's say that we are designing an employment management tool. The first thing you would do, going back to the whiteboarding session, we're going to start whiteboarding. The most important thing in an employment management tool is an employee. And you're going to say, well, an employee has a first name, last name, salary. Most probably at some point you're going to bring business people, designers, and you're going to start discussing, should we have projects, and should projects have start dates, and what about employee feedbacks, and is salary a float or a decimal? How are we going to save this, and how are we going to structure all these things? Once you have that sorted, the core of the problem you're trying to solve, that's the model proper. But there is also like the other side, which I'm calling here mechanical aspects, because this is the picture that I have in mind when I think about the mechanical aspects, or things that are very repetitive, and we keep addressing them over and over again. Some examples. We keep addressing database schemas. We always have to convert that model at some point. It was even kind of my example. How are we going to save this? Where are we going to save this? Do we need Elasticsearch? Do we need whatever? How are we going to query this? Do we expose this via an API? Which kind of API do we use? Do we use REST, GraphQL? And it goes on and on. How do we actually deal with data validation? How do we package this? Do we need to transform? Multiple layers of transformers. Do we need to generate data for testing or enforce security one way or another? In all these concerns, they are super valid concerns, but they do not necessarily address the core of the problem. They do not necessarily address the fact that it is an employment management system. Every time we talk about test data generation, for instance, which is a very fascinating subject, the business people who care about an employee and the salary of the employee, they don't really care. They are like, I just need the employee and the employee's salary. Why are you guys talking about task generation? We have to explain and etc. There is a little bit of a mismatch when we talk about these problems. And even in the code, you probably have seen this before, because any reasonably sized project will mix those two concerns. We'll mix the business concerns and the mechanical concerns, and they will kind of intermingle. And in my experience during the last couple of years, first, this is very repetitive. So if you decide that now you need a full name in that employee entity, or whatever we call that thing, now you have to actually go through every single layer of your mechanical structure and add to the database, add to your validation tier, add to your API, make sure you rewrote the tests. And it's very repetitive, because two weeks from now, you have another sprint, and there will be another new field, and you have to do the same work over and over again. Exactly because it's repetitive, it's also very error-prone. You're going to be forgetting things along the way. You're going to have to create disciplines around your team, and it's really annoying. And the worst thing for me is the fact that you will end up with situations where parts of your logic, your business logic, will be scattered all over the place. One of the examples, because I see this in almost every single scenario, or every single system we build, is a security layer. Because security kind of sits in between an auxiliary concern and a core concern. And by security, what I mean in practice is, there is a node in your chart, the person's salary in this case, because it's an employee, only managers can actually access that field. And this is a business requirement. Someone actually said it's only for managers. Where do you put that? Do you put that all the way down, closer to your database? Do you put that at your API level? Do you have a tier in between? And do you remember where you have put it the last time that you had that problem? Or when it changes, because now it's not managers anymore, now it's directors. It's a pain, yes. If you haven't been through those pains, I'm alone. So the dream for me is like, again, system would be a gigantic function of logic, state, and model. Logic, a collection of functions, the state, initial state, and the transactions, model, the domain proper, and mechanical. And for us, of course, it's a Clojure conference. Functions, we're just talking about Clojure itself. Clojure is amazing to do that. For state, my personal preference has been Datomic because it represents the data exactly like this. It doesn't have to be, but it fits within my dream. However, there is something missing. There is a missing link there on representing the model proper and the mechanical parts of the model. So, of course, I ended up creating my own open source project to try to solve this. It's been like my work of my labor for the last year or so, called Holder. And it's not to be confused with Hodor. And then, of course, I'm a foreigner, so I don't know if I'm pronouncing it right, but it's Hodor with U, not Hodor with O. So back to the dream, look, that's how I see it, like Clojure, Datomic, and then something that I created to fill that gap. Holder has 4 simple principles, and I want to walk you guys through very quickly. First one is something very obvious for us, Clojurians and Clojurists in general. Model is just data. So when I started dreaming about this, I started actually writing stuff like this. Just my entities, the stuff that I need to describe, they're just symbols on an Eden file. Straight and forward, super directly, super easy. And of course, it's very incomplete as well. So I needed to actually start expanding that a little bit. An employee has first name, last name, project has name, an invoice probably has more things. And I have to say, I was pretty content with this already. Like, this was already very, very, very interesting. But I started actually having to hint a few things around. For instance, in this very example, date is kind of different than a first name, because first name is, I'm kind of expecting a string. Date, I'm kind of expecting an instant. So, how do I describe that? And then it came to me that I could use metadata, to do that, because metadata doesn't change the structure, the basic structure of your data, as we're seeing with Stuart this morning, but adds this kind of like extra dimension to my data structure, and also allowed me to do things like this. What if I have a self-referential entity there, like an employee has a supervisor, a project has multiple employees. And then I was able to do stuff like this, right? A supervisor is just a metadata of an employee, and I expanded the metadata structure a little bit with a map for multiple cardinalities, like 0 to n in this case. So I know that a project has multiple, from 0 to n, infinite number of employees. If you really think about this, it's the core of what we're trying to solve. It's like just describing the domain problem. Second principle within Holder, every single model should be queryable. And it is kind of like building this surface around your model, like this meta API that you can query your model. And the reason why I came up with this idea is because what if you're passing your model around and you have crazy questions? For example, let's assume that this is my model. I'm just initializing. I'm already using Holder there, initializing the employee in the project, creating this def called MetaDB. And what if someone else actually built that model to me, and they're just passing this model around as data, and I want to know if we have any field that has 0 to n cardinality. And the way that I implemented this was using DataScript, in-memory querying in an in-memory database. So in this example here, I actually wrote exactly the answer to that question, right? Or the query that I run against my Meta API to get that answer. It's a simple, data log saying, well, you know what, give me a node that happens to be a field, give me a field that happens to have cardinality from 0 to n, and when I evolved this, I got 13. It's the internal ID of this node within my API, my meta API. Of course, because it's data script that implements also data pool, so you can also write your pool language there and say like, you know what, I don't want the ID, I want to know the name of this field, and I know it's employees. It was the only one that we had with this in there. Once again, because it's data script and you can use pool and whatnot, you can actually start to traverse your nodes and get not only the name of the field, but also the parent and the name of the parent. So the response here, I know that I have a field name called employees whose parent is a project. The beauty of this is that then leads me to my third principle here. One model to rule them all, and many views around this model. Or the way that I draw this is like building these layers of this onion. You start with the domain model, meta API around it, and now I can see all these different schemas and views. And in fact, just because like this has been so useful to us in our projects, we already have a bunch of, we call them plugins, that give us completely different access to, and they are all open source as well. So one for Graphics, one for Datomic, Contentful. Let's see, whatever we need, we just write one. We write a new schema, and we plug this in this modular architecture. And one that I really want to show you guys is one that we called Visualizer. We didn't have a name for it, so I don't know about you, but I have been always very jealous of our front-end people because they have that hot reload thing. They change on the code and hot reloads. And I really wanted my model to be hot reloaded as well. So this is what Visualizer does. And I'm going to show like a quick demo here. It's part of the example project. I'm just calling out an alias that will I have my browser on the right-hand side, and this is something we do when we're brainstorming now. This is our new whiteboard. So that model got represented by this, and on the left-hand side, I have my Emacs. So here's my model, and let's say that I want to add a full name side by side with first and last. So I'm going to add that there, save, and now my model, of course, has the full name as well. And the beauty of this is that we have been using this for brainstorming with clients, with business people and design people as well. Because they say, well, what about an invoice? And we put the invoice there and say like, well, but the invoice is not connected to anything. Well, is it connected to an employee? Is that connected to a project? And then they say like, well, yeah, we all agree maybe it is. Each project has many invoices, and then we plug it there and we see how it looks like. Of course, because I do use a tiny library to do this. You can drag and drop. You can collapse things. And once we are happy with this, our process has been, once we are happy with this kind of like iterative approach in designing the model and talking this shared language with everyone in the project, including non-technical people, we document this. And we have a separate schema, a separate layer on this onion that we were building here that generates a PNG using Graphics and just like saves that on GitHub so that we can always refer back to it or even use that as part of our documentation or send that as an email attachment. It was very funny, like some of our clients, they start actually printing those diagrams and actually adding notes on these diagrams and then scanning them back and sending them back to us, which is fascinating. Like it's the first time this has happened. And of course, the whole thing scales quite well as long as you can zoom in and out of your model in certain parts. So this is like one section of one of the systems we're building with this, running on that visualizer. Of course, it's super tiny, but that's just to show that this was my web page, and I could actually zoom in and out and scroll. And I could also like just generate the visualizer just for one part as well if I need to. Other kind of views or schemas, the Datomic view of our code. We have a Datomic plugin. You just call the Datomic plugin, which in this case is called holder Datomic in this require. Function schema, you pass the MetaDB, because it talks the same language, it just spits out your Datomic schema, and you can transact that schema into Datomic, and you're ready to go. You already have a database. Do you like SPEC? We like SPEC quite a bit. So we also have a macro called DefSpecs in a separate module that just reads the whole thing, spits a whole bunch of specs for you, and a few helpers as well along the way, because SPEC is so powerful. We also extended Holder a little bit because it's all meta-based, so you can always add meta markers to communicate back to some of these plugins. So we can also add custom generators and override and extend some of these validations as well if you're not happy with the default behavior. And last point, and I think that this one we're going to spend a little bit more time. One of the last principle from Holder is you have to let machines do what machines do best. They do machine stuff, so let's let them do what they have to do. And to get there, I want to actually go through putting everything together and do a little bit of a reference implementation. So let's start with the employee project model that we already have. I'll extend it very quickly to add queries and pagination because they're kind of annoying things that we have to add as part of any project. And then I want to deploy this on using Datomic DB, exposing everything through GraphQL. I'm going to be using Luchini, and deploy this on Datomic Cloud and Ions. So quick primer about the Datomic Ions, because some of you might not have used. The beauty of Datomic Ions is the power of Datomic, all the database stuff that you already have, plus the idea that you can run your functions on the cloud. And every single week I have to say this to someone. Like, it doesn't mean that we're running, because talk about running functions on the cloud, it's not Lambda. However, I understand where people are coming from, because when you show this diagram of what the Datomic Ions is, you do have lambdas in the picture, so you always have to remember that lambdas are just proxying stuff. But how does it work in 5 steps? Very quickly. First, write your function. And it's that simple, right? It's just a simple function. The way that Datomic Ions actually work, you have this Datomic Ion config, which is searched on the class path. It is an Eden file that you just described that you want to expose that one function that I call hello from cloud. You want to expose that through a Lambda proxy, and then you're good to go on this step 1. Step 2, you're going to push this online. You're going to push this to AWS. The command you're going to use is this Datomic Ion dev using this operation push. And what it does is that it's going to create a nice revision for you on code deploy. It's going to use the SHA of your commit. So it's going to kind of automatically version for you if you're really well disciplined, and it's a great feature. Third step out of 5, deploy. Revision doesn't mean that it got deployed. It's just an artifact that needs to be deployed on a system. So deploy, you also use the same command but with a different operation called deploy. You specify the revision you want to deploy, the commit SHA, and the computing group that you want to deploy it to, which in this case, I'm actually assuming that I have a computing group for just quality assurance purposes that I called QA. It's one of the conventions we've been using internally. When that runs, you will end up, of course, with a Lambda. The Lambda is going to be prefaced with a computing group name, so it's going to be QA and the name of the Lambda you gave. And if you want to just call this Lambda directly, great. Just use AWS, invoke, and that's it. Your code was called all the way down on your EC2 instance. Fourth step out of 5, the plumbing. I call it plumbing because for me it is you have already coded locally, you have developed locally, you have already deployed as a proxy Lambda, also as part of your EC2 computing group. But now you need to actually deal with that extra arrow called config. That extra arrow config is where you're going to actually put all these plumbing things, configurations on AWS saying, well, you know what, I need to trigger this Lambda when someone uploads an S3 file, a file to S3 bucket, or when someone hits this endpoint through API gateway, or whatever it is, right, that you will use as part of the services on AWS. And step 5 out of 5, that's my preferred one. You just go home. There is nothing else. Literally, the part that actually sold me on this was when I started from scratch, and it took me 25 minutes to get to this spot. So definitely it's a good one. GraphQL specifically is great as a target for Datomic Ions because GraphQL has only one endpoint anyway, so it's even simpler on the plumbing side because the only thing you need to do is create on your API gateway just one endpoint called GraphQL, and you're good to go. Like, you don't have to worry about anything else. And so let's just start with that project employee model that I had already on Visualizer. I did extend a few more things here, so I'm adding some pagination entities there. They are a little bit more evolved. They are called reportees. Yeah, I have also like a reverse query just to make it harder. I also broke down my domains, my domain model on a separate file that I called schemas, and I have like all those things listed here. And as you can see, of course, it took me a while to build this file, but here I have all the markers of everything I need for my model, and then I'm going to be adding them like slowly but surely. I have the basic employee and project, and I'm going to add first all the pagination stuff that I created. I created a few things here. In the GraphQL world, you end up creating this connector objects like an employee list and a project list, and all these guys connect back to a page info that gives you some metadata about the page you're in and how to navigate around. And also because GraphQL is a little bit limited, it's not a true graph-based system. You need to start with a root level for your queries. I also have like one separate schema here that adds a gigantic piece of infrastructure, which I don't really appreciate much, but it's like one entity that is the entry point for all the different graphs that I need. These are all kind of specific. You know, I've been kind of forced to do some of the mechanical stuff here to kind of help some of these other things, which is kind of annoying and defeats some of the purpose of what I'm trying to build. But it still shows how some of these technologies are kind of lagging behind from where it would be good from a vision perspective. And once I have all these things in place, I call my Luchini. I just, of course, require that, add that as a dependency in my dapps file, require holder Luchini, call the function schema, and it's super tiny on the right-hand side because like this is all code that you would have to actually do and manage yourself if you wanted to actually do that model on Luchini. I didn't write a line of that. That was generated by one line of code and just three if you count the require as well. Same stuff for Datomic. So I also import that, require, call the function. I also have a model for Datomic. So going back to this drawing, the onion one that I'm building here. So the domain, the meta, and we already have stuff. But what we're trying to do is let machines do what they do best. And this is kind of experimental, but it's the outer layer of this onion, which I have been calling adapter. And the idea of adapters here is that they would connect some of these views. They would have awareness of the underlying views, and they would be able to connect two of these views in kind of an automatic way or a machine-like way. So I created one very quickly for this talk between Luchini and Datomic. I've also published that as a pre-alpha open source library if you want to try it. And the way that you configure it is like you give all these hints about what you really want. So for instance, I have a query root that gives me an employee, and I'm giving this hint. I'm saying like, you know what? This node employee is a query of type 1. So it will know that when it creates a query on Datomic, that it has to actually do a pull instead of a normal query. And I also say like, you know what? The email parameter is also the lookup ref, and then use this lookup ref when going down Datomic. So I have to still do some of that configuration, but it's configuration instead of coding this by hand. A little bit more complicated example, if you want to get all the employees and you have some search field like a name search, also it's paginated, so I also have to mark each one of the pagination fields that are parameters that I'm using, saying which one is optional, which one is not. And here, one thing that is interesting, searching sometimes is not trivial. So I made this example not trivial, and it's a bit contrived, but I'm searching by first name, last name, full name, different parts using Datomic's index. So I ended up creating this hook called name search that does all what I call like the filter builder. That will be your logic, basically. This is kind of like going back to my system function. This is your logic part of the system function. And I want to show this working. Like once you have all these things in place, I start with the visualizer. That was the one we saw originally. And then showing this on Datomic is fascinating because I start by pushing. So I run that push command from Datomic Ion Dev. And this is going to create a revision on AWS, code deploy on AWS. It's already there. And the next command that I'll run is a deploy. I really want to deploy this. And I'm choosing, I'm deploying that very specific commit that I just pushed. And the interesting thing about deploy is that it's asynchronous, so it will give me an OK right away. But then it also gives me a command that I can run to check the status of the deployment. And I'm going to run that status here just to check that it's running, it hasn't failed. And then, of course, you can run it like over and over again if you really have the patience. I ran it twice just to make sure. And while it was running, like just to show it on the AWS side, because I think it's fascinating, if you go to code deploy as a product, you will be able to see that revision being deployed. And this is really exploded from a size perspective, but I went to deployment, and you see my deployment is in progress. Let's see more information. And while I was doing it, it succeeded. You know, it's now green lighted. And just to make totally perfect, ensure that it has deployed, I'm going to run that status command again, and you see that it succeeded. The beauty of using code deploy here is that this specific cluster had 2 EC2 instances, so it did the rollout. It did the whole deployment, trying to be as zero downtime as possible, which is a lot of work if you're not doing this. Like if you're not using this, and this came kind of for free with Datomic, that was my selling point. And once that's done, I'm going to show the plumbing side, going on to API Gateway. And on API Gateway, I had already set up a very simple endpoint called GraphQL, like showing it very quickly. It's just a Lambda proxy. And the most important thing here, of course, is to grab the invoke URL so that I can hit this Lambda and test it out. And what I'll do now is I'm going to copy and paste that, and I'm going to run a graphical client. We use a generic one. This is the generic one that I like. I'm putting the whole path with the GraphQL at the end. Every single person in our team uses this terminal, this app. It's not only for developers. This is used by QA, and by business people and designers alike. You have the documentation on the right-hand side. This is very GraphQL specific. I didn't put a lot of documentation in the model to keep it simple, but like you can surf around, you can see like, whoa, this is going to return a list of employees. This returns a page description. This returns an employee. But the most fascinating thing is like you can already start typing your queries here, and there is autocomplete and whatnot. Literally, this takes between 30 minutes to an hour for anyone with computer basic skills to basic computer skills to learn and listen what's happening. I want an employee, I just put my email, first name, last name, full name. Then if I want more stuff, like I want reportees, the total count of reportees that I have is like 3. This is a reverse lookup already through Datomic. I want to know the first name and last name of all those reportees. There you go, you know, super straightforward. And a more advanced one, a little bit more interesting, is like if I go through and I want all the employees, because this is implementing pagination, and the custom logic that I wrote for the query. So just putting name search, and anyone would start with FE, first name and last name as a node, and I also want to know how many we have in the database. So there are 3, and you know the 3 came up. I think that the default limit is like 50 or 100, so super high. Of course, it works with whatever I put there. You can run as many tests as you want. But the one thing that I want to do here is also show you the pagination with a optional field. I'm limiting to 2. I still see 3 as total count, but now I only see 2 results here. And I can get more information about the pages and even some meta information, like for UI. This is awesome because you know, just check whether there is a has next, and if there is a has next, you can actually show the links. And if you go back to the objectives we had, we started with that simple model we had. We extended it, and we deployed it on Datomic DB using GraphQL and on Datomic Cloud Ions. Some of the takeaways: system is that simple, right? A function of logic, state, and model. In my world, this is the way that I like doing this. You know, Clojure, Datomic, and Holder. It doesn't need to be this, but it's a good value to have. Model is just data. Don't overcomplicate it. Models should be queryable. I think that this is kind of a universal truth. One model, many views, something that I really appreciate. I like letting machines do what machines do best. And I think that one of the most important things also with Datomic Ions is that you're getting hosting and persistent storage made easy. Thank you very much.